Today we're talking about infinite series, and before we get into that, we're going to just review a few terms. So remember, a sub 1, that's your first term, r is your common ratio, and s sub n is the sum of n terms. So when we talk about infinite series, we're talking about series that just keeps going on forever. To give you a few examples of an infinite series, we can think of a ball that's bouncing, and it'll bounce back a fraction of its height forever in theory, but we know that in reality it actually comes to a stop. Pendulum will just swing back and forth forever in the same manner. And so let's take a look at this example. What's an infinite sum of a series with your first term being 3 and your common ratio being 2. So if you just think about this for a minute, if we just keep going on, we would have 3 as our first term, and we're just going to multiply that by 2, and so on. And you're just going to continue to multiply by 2, continue to add up all of those terms. And you can see that eventually this value is going to be approaching infinity because it's just going to keep getting larger and larger. And that's, again, with your common ratio being 2. In the next example, our common ratio is 0.5. So our first term is 2, and I just want to kind of show you what this is going to be doing. So I'm going to take 2, and I'm going to multiply that by 0.5, or 1/2, or divide it by 2 each time. And I'm going to be adding up all of these terms. So all I'm doing is dividing by 2 each time to get to the next term. And you can see the number that we're adding onto it is getting smaller and smaller as we go. So just to give you an example, if I were to add up the first 1, 2, 3, 4, 5, 6 terms here, that's going to give me 3.9375. And if I keep going and add on a few more terms, I'm going to take half of this number. That's going to give me that, half of that number. And so on. And if we keep adding up those numbers, this sum right here is 3.9921875. So as we can see, the more numbers we're adding on, it goes from here to here. And eventually, if we keep adding up all of the numbers, we're going to get 4. And there's a formula that does this for us, but I just wanted you to kind of see where we get this from. So as we saw in the first example, the numbers were just going to continue to get larger and larger and eventually approach infinity. And we call that diverging. And other times, as we saw in the second example, the series seem to add up to a certain number, and that's when it converges. So here's the general rule. First, we want to figure out what the common ratio is, and we're going to take the absolute value of that. So if that common ratio, the absolute value of that common ratio, is less than 1, then the series converges. It becomes just a number. If it's greater than or equal to 1, then it diverges and it becomes, it approaches infinity. And so here's the formula. So this is when the absolute value of r is less than 1. Here's the formula we're going to use. And so this is the sum of an infinite series. That's what this notation represents. And if that absolute value of r is greater than or equal to 1, then it's going to be approaching infinity. So let's look at a couple examples here. So we want to find the infinite sum of this series with the first term being 1/2 and the ratio is 3/4. So I'm going to use the formula that we just saw in the previous slide. So this is the infinite sum of this series is equal to the first term over 1 minus your common ratio. So this is going to be 1/2 over 1 minus 3/4. And we can certainly simplify this. So 1 minus 3/4 is 1/4. And that's the same thing as 1/2 divided by 1/4. Keep change flip. 1/2 times 4/1, which is 2. This is just another way of asking the same type of question. So it still wants the sum of the series. Remember the summation notation here, sigma. And so we can see that our common ratio is 1/2. In our first term, if we plug in 1 for n, we would get 3 times 1/2 to the 1 minus 1 power, or to the 0 power. So our first term is going to be 3 times 1, which is 3. And so this infinite sum of this series is going to be 3 over 1 minus 1/2, or 3 over 1/2. 3 divided by 1/2, or 3 times 2, which is 6. And we will continue all of this in class. See you then.